Hello everyone. So the topic for the session is linear regression. So what is regression and what is linear regression? So basically there are many different definitions for this term linear regression. But as from my perspective, linear regression is an approach or technique to model the relationship between a scalar response and one or more explanatory variables. So what does it mean? This means we are modeling or predicting a variable y which is scalar or numeric in linear regression, and there are one or more explanatory variables. So what does it mean? Sorry so modeling any variable y which is scalar, and there are one or more variables, one or more explanatory variables. So there are two types of linear regression: simple linear regression and multiple linear regression. So as the term suggests, simple linear regression is one in which there is only one explanatory variable, and multiple linear regression is which in there may be n number of variables explaining the model. There is no limit to such. There can be three variables, four variables, five variables, and n number of variables explaining the model. But in simple linear regression, there is only one variable responsible for the model. So as this is a very vast topic, so this video will mainly focus on simple linear regression. One explanatory variables. And in multiple linear regression, there can be n number of explaining variables. So this video will mainly focus on simple linear regression. So now let's take a sample data on which we will be working. So here is my sample data set. So you can see here are two fields: number of employees and average number of tickets. So now let's write down the basic formula for calculating regression. The basic formula for regression is this: y is equal to mx plus c. Now what is y, what is m, what is x, and what is c here? So we will be talking about this. So y is our target variable which we will be predicting. M is the slope. Now what is slope? Slope is the rate of change of y when x changes, when the variable which is explaining the model changes. For each change in x, what is the change in y? That is slope. What is x here? X is the only variable explaining the model. Bichara. value of explanatory variable x. And what is C? C is the intercept. Now what does this term intercept means? This term intercept means the value of y when x is 0. So I think this equation is clear. Now let's start working on the data. Now we are working on Excel, and in Excel there are pre-built functions with the help of which we can calculate all these fields. See, we will be calculating these fields. So in Excel there is a formula equals to slope. Now it takes two field parameters to be passed on. First is all the values of y's. We can select these values of y's, and these all the values of x. So our slope for the data is 0.183317, which means for each number of ticket increased, the number of employees increased will be 0.18. For example, 51 employees can handle 5 tickets per day. So if a ticket is increased, for example 5 tickets are now, so tomorrow 6 tickets needs to be handled. So what is the probability that how many number of employees will be required to handle those tickets? So that is 0.18. Alright, so now let's move on to the another intercept. So in Excel we have intercept. Again the same fields needs to be passed. Sorry. Intercept. This means what is the value of y when x is 0. So this is intercept. Now there is another term, coefficient of correlation. What does it mean? This term means that what is the probability that this model is explaining all the values responsible for the model. Coefficient of correlation. So this is the basically its values lies between -1 to 1, and if the value is closer to 1, it means our model is a strong model or a very strong model, and if its value is approaching to 0, then our model is weak. So to calculate the coefficient of correlation, we have the formula is equal to correl. Again we need to pass the same parameters. So we are getting 0.987109, which is approximately 1. So these values are indicating a very strong relationship between both of them. So now to verify this, so there is another term, coefficient R square or coefficient of determination. R squared. It is basically the square of coefficient of correlation, and it is the probability that all the variances or all the variances in the target variable they are explained by the model. For example, there are 10 values, 10 records in our data. Suppose there are 21 records in our data, and out of 21, almost 18 are 100% dependent or correlated between each other. So our coefficient of correlation will be 18 by 21. That means 18 values out of 21 records are explaining the relationship between. So 18 records out of 21 are explaining the relationship between each other, and the value of r square lies between 0 to 1 as it is r squared value. So in general, value greater than 0.7, greater than 0. Is considered to be a strong model, and values greater than 0.5 are considered to be good model, and value less than 0.3 are considered to be not useful. So this is the basics of r square. Now let us calculate the r square value of this for this data. So we have the formula RSQ. Now again we have to pass the same parameters. So here we have the r square value. So you can see we can verify the same by taking square of r square coefficient of correlation. So here we have verified the same. Now let us predict. Now let us apply this all what we have learned. Now let us suppose in the next year we are assuming that there will be 525 employees in our company. Now what is the forecasted or predicted idea that how many tickets we are able to process in a particular day? So we will be predicting by what we have learned. Now let's revising the equation of the regression. So what is y here? Y is we are predicting the average number of tickets, and what is m? So m is our slope, and what is x? X is the predicted number of employees, and what is c? C is our intercept. So here we have predicted. So what does this value means? That this term means that with the help of 525 employees we are able to process around 85 tickets in a day. That 525 employees can process 85 tickets per day. So this is how we apply simple linear regression. So any doubts or any questions till now? Okay. So this was for the day. Thank you so much. Have a nice day.